Welcome to module 2 of design of two-story building. Okay, in this module we will run the analysis and design of this two-story building. So let's go back to the plan. Switch to the plan. Okay, we will quickly do a setting, building analysis. Click on that. Come to project parameters, foundation. Here you insert the soil bearing capacity. Then here you can insert the project header. For instance, design of proposed story building. For school block. Then here you put your name. If you are the one designing, you put your name here. Then you put the name of the engineer that will check your work. Then you put your project number. Then here you put your project date. You click OK. The next setting that you will do is material settings. So you click here to edit your material. So you can start with concrete. We are using 2025 concrete. So you click on that, then you apply to all members. Okay, so it will apply to all members. Then for the concrete grade, you click on 14. Then the same thing apply to all members. So you don't have need of editing the one after the other. But for the river, you have to do it because of the different structural elements. So for column, you uncheck this Y16. So we are going to make use of Y16 and Y20. So you uncheck other rivers. So we are making use of Y20 and Y16. Then we don't have concrete wall. So the next one is beam. So beam, we can also make use of Y16 and Y20. Then you uncheck others. Then for slab we will use Y10 for the distribution, then Y12 for the main reinforcement. Then uncheck others. Then for link we are making use of Y10. So link is Y10. Okay, so we have edit the material properties. So you close. We want to fix the slab strip, that is the reinforcement on the slab. So you click on slab strip. Here you have to be very careful you have to understand this limit status so that you can actually make use of it. So let's define this axis. So here we have x and we have y. The y is on this direction. Now when you are making use of y, it's going to be on this direction. But when you are making use of x, it's going to be on this direction. So our main reinforcement is going to be on this direction. So we have to make use of x. It's going to be on this direction, main reinforcement. So we are going to use the start. We are going to make use of this and also make use of this, because this is discontinuous edge and this is also discontinuous edge. So for the start, we are going to click here and also click here. So you hold your control key to make the reinforcement straight. Make sure you hold your control key so that your reinforcement can be straight. Okay, so let's go back. Let's go back and do that. We didn't check we did not activate the load combination, so we have to do that. Click on load combination generator, click on OK, then click on load cases, click on OK. So we can now go back and place our reinforcement. So So we are done with placing the main reinforcement. So the next one will be the second reinforcement at near bottom. So you change the direction to Y. So you go back, click on this, so here we come. Okay, so we have finished placing our reinforcement in the first floor slab. So we will do the same in the second floor slab. So let's go to the second floor. So as we did it before, we start with the X direction. Make sure you hold your control key. Okay, we have finished placing the reinforcement on the second floor slab. Okay, the next thing we are going to do right now will be to run the analysis. There are 4 types of analysis in Prota structure. We have the building analysis, we have the heavy flow analysis, which is finite element flow analysis. Now finite element analysis has 2, heavy flow and heavy flow mesh analysis. Then we have the wrap flow foundation. So when you are running analysis, you can only do one. You can only choose one. It's either you choose building analysis or you choose FE flow analysis. So in this case, we are going to choose building analysis. I think I will do a video that we will use FE flow analysis. So for now, we are going to concentrate with building analysis. So you click on building analysis. We have already set our parameters. So what we do next is to click on analysis. You click on building check model to ensure that your models are okay. Okay, operation completed. Numbers of error 0. It's closed. So you run building analysis. Now, batch design option. We are not going to click on any of these because we will do the design individually. That we are going to design each element separately. So we are not going to run the overall design. If you check any of these boxes as he is running the analysis, immediately he's done with the analysis, he will carry out the design. So we don't want it to carry out the design without us doing further setting. So we only click on this building analysis and wait for it to run. One thing that is very outstanding and unique about Prota structure software is that unlike some other software that you need to run the analysis on each of the structural elements, but when it comes to Prota structure, you run the analysis. The analysis will run on all the structural elements. So that is one powerful and unique thing about Prota structure. So it has successfully run the analysis of the entire structure. So the next thing we are going to do is to carry out our design. So you click on close. You close this analytical model. Then you go back to building analysis. Here you click on post analysis. So click on column. So we are going to do some setting here. So you click on setting and parameters. Setting and parameters. So here you do some setting. So column bar Y16 minimum, Y16 maximum. Okay, then here cover. We are using 40 as our cover. So link. Here I want my link spacing to be at 250. Though at the end of the design, Prota structure will provide the appropriate link spacing. So you can stand here and set everything. So I am done with the with the column. Then I click on beam setting, click on design, click on parameters. Then here I select minimum beam steel diameter, which is 16, maximum 20. The minimum numbers of hangers 2. Minimum number of diameter 16. Link 10. Cover 25. Okay. Link. You click on standard. We are done with that. We move to slab design. Cover 20. Minimum steel 10. Bar spacing. Minimum should be 150. The maximum should be 250. Then slab steel bar cut length. This is 12 mm, so it's okay. That is the standard length of reinforcement in Nigeria. Then foundation. Okay, this 450. 450. Bar spacing using 150. Okay, let's use 200. Concrete cover. Yes, concrete cover 50. Then link to music blinding using 75. 75. I'll click on OK. Okay, so the next is to run the design. So you click on column design batch view. You click on reselect all bars. Click on close. So as you can see, some of the column are not passing, so we click on each of the column that are not passing. So when you play, you go to reset, you click OK. Go to reset bar, click OK. Reset bar, click OK. Reset bar, click OK. So we have been able to check all the column that was not passing. So all the column that were not passing, so we have checked that pass now. So the next design we will do will be that of beam. So you simply click on beam design bar mode, select all bars. So all our beams have passed. Okay, so the next element that we are going to design will be footing. So let's go to footing. So you highlight everything, you right click, go to insert part footing. Click on OK. Okay, so all the footings have been designed. All our footings have been designed. Okay, we can actually get the load that is acting at each of these footings. can actually give the load that is acting at each of these columns. So if you want to get the magnitude of that load, you want to see the magnitude of the load, so what you do, you come to display, you come to visual interrogation, then you come to where you have column display, click on here, click on this, then you come here, you click on dead load. If you need only the dead load, you can just click on that. If you need dead load and live load, you click here, then you click OK. So these are the loads that is acting at each of these column points. So these are the loads. So if you want to carry out manual design, you can come here, pick this load direct, and design your column manually. Okay, so let's look at the final model in 3D. Okay, so yeah, this is how our design looks like. This is how our design looks like. Okay, the next thing I want to show you, for instance, if you are detailing your beam manually, how do you get the beam reinforcement on each of the beam? So for instance, if this is your beam 1, so let's get the reinforcement that is in this beam 1. So you click, right click, go to section design. Okay, you come to detail drawing. Okay, so this is for you to get the reinforcement that is in that beam. Is how you get it. So there are some people that carry out their design manual, their detailing manually. So they don't use Prota structure detailing. So this is how you get each of the reinforcement in each beam. So you can come here and see the section. This is section 3.3. Let's look at section 3. This is section 3.3. This is section 3.3. This is section 3.3. So we have 4Y. So here at this support, we have additional 2 reinforcement. Remember that we have 2 reinforcement here, and these two reinforcement run from here to here. So in addition to these 2 reinforcement, we have another 2 reinforcement. So at the support we have 4 reinforcement at the support, but at the bottom we have just 2. Then here this one is just hanger, 2Y16 as a hanger. This one also is a hanger, but from here to this point we have 4Y16. So you can see it here in the section. Okay. Okay. Then if you want to print the calculation sheet for the beam, so what you need to do is go back to building analysis, go back to building analysis, you go back to post analysis for the beam. You come to where you have design report, so you click on design report. It will take some time because the report is much. So this is the report has been generated, so you can print this out. You can print this out. So to generate a report for the column, you go back to column, click on column, go to report, click on design report, you check all this, then click on OK. So this is the column report. print this out. If you want to print it out, you can print it out. Okay, let's see how we can also generate report for footing. Okay, let's generate for slab. You go to analysis, you go to so to generate report for the slab, you click on slab, check design, do not modify existing steel, check design, only select insufficient steel. So you go with this one, then you click on design. So automatically it has finished designing the slab. So this is the slab result. This is the result of the slab. So you can save this or print it out. You can save it or print it out. That is to get the slab result. You click on design, you come to where you have slab analysis, you click on slab analysis, then you check this, then click on design. So by the time you finish designing, automatically the entire result will come out. Okay, so let's go for the footings. You click on footings. For instance, if you want to generate the result for this footing, what you need to do, you click right click, go to show footings report. So you click on show footings report. So this is the footings report. Okay, so you can print it out. So I think we will stop our class here for today. If you have not subscribed to our channel, please do us a favor by clicking on the subscribe button, and feel free to drop your comments. So that is how far we can go for the modeling of 2-floor classroom block. I believe that you have learned something. Feel free to drop your comments, and I sincerely appreciate you. Thank you very much for watching our video. I hope forward to have you in our next video. Thank you. Bye bye.